Hello everyone. Today I am going to tell you about JK flip-flops and derive its truth table. Firstly, JK flip-flop was invented by JK Nelson. It was basically to overcome the drawback of RS flip-flop, which was that in RS flip-flops truth table, the 1-1 condition is called the intermediate change, or the condition is not possible. Okay, so let's get started. J&K flip-flop is little more complicated than RS flip-flop and requires 4 NAND gates. Therefore, we should know the truth table for the NAND gates. We need to make a 3 input NAND gate table. NAND gate is nothing but inversion of AND gate, or not AND. Let's make the table. Suppose A, B, C are the 3 inputs and Y is the output. Okay, let's make the table. Zero one one 0 1 0 1 1. Okay, as you know, we have taken 3 inputs, so the possible outcomes would be 2 raised to power n, which is 2 raised to power 3, which is 8. 1 2 3 4 5 6 7 8. So first we will find the AND gate for ABC, which is AND gate would be 0, so not of 0 would be 1. AND gate for this outcome would be 0, so the NAND would be also 1. Similarly, we can find up till this 1 1 1 1 0. Let's make the circuit diagram for J&K flip-flop. It will consist of 4 NAND gates, 1 2 3 and 4. Let's connect it. Let name it as Qn, therefore it would be Qn dash, and let the output be Qn plus 1 and Qn plus 1 dash. Here the NAND gate 2 and 4 are the active low conditions, which means that whenever the output from 1 and 3 would be 0, either 1 or 3 would be 0, then there would be a change in the output. And NAND gates 1 and 3 are the gate firing terminals, where the output from as you know, there are three inputs, 1 2 3, J, clock and Qn, and that's why we made the NAND gate at the beginning, and it will just give the output as it is here. Let's see how the truth table works. We are implying two inputs J and K, therefore there would be 4 outcomes, that is 0 0 1 0 0 1 and 1 1. Now let's make the truth table J K, and we have two active low outputs, that is Qn and Qn dash. Qn dash. Now let the first inputs would be 0 and 0. There would be two possible outcomes of Qn and Qn dash, that is 1 0 or 0 1. When Qn is at set mode, the Qn dash should be naturally at reset mode. 0 represent reset and 1 represent set mode. We need to find Qn plus 1 and Qn plus 1 dash and the state of the output. Okay then. Now let's try to find it out. We are putting the inputs J and K 0 0. J 0, K is also 0. Let the clock pulse be 0 or 1. Yeah, at the beginning, if we imply clock pulse as 0, whatever maybe the input is, the memory does not change. When clock pulse is 0, we are checking the conditions when the clock pulse is 1 or enabled. Okay, this is 1, this is 0, J and K are 0. Let the first case Qn be 1 and 0, Qn is 1 and Qn dash would be 0. Now let's check for the NAND gate 1 and 3. Here for J it is 0 0. The 0 will travel through this path 0 and the clock pulse 1 0 0 1. The NAND gate for 0 0 1 is 1. That means the outcome would be 1. Similarly, for NAND gate 3 0 1 from the clock pulse and from here 1 1, that is 0 1 1. The outcome is again 1. As I have said that this 2 and 4 are in active low conditions. The output will only change if there is 0 in this position. As you are seeing that only 1 are existing in both the paths, therefore there would be no change in the output, and Qn and Qn dash would be equal to Qn plus 1 and Qn plus 1 dash. So we will write 1 0 as it is. Now for the second state 0 1, when Qn is equals to 1 and Qn dash Qn is equals to 0, Qn dash is equals to 1. Qn dash is equals to 1. Now again repeating the same procedure. J0, clock pulse 1. Now from here 1 would travel to J, that means the new outcome would be 1 0 1, and AND gate for 1 0 1 is 1. Similarly for K0, Q would be 0 and clock pulse 1, therefore the new outcome would be 0 0 1, and again the outcome would be 1, and 2 and 4 are in active low condition, therefore no change, and the output remains the same 0 1. Now as you can see that Qn and Qn dash are equal to Qn plus 1 and Qn dash plus 1, therefore we can say that the state is at no change. Now let's solve for 1 0 condition. Outcome would be 1 0 and 0 1. Now we will find for Qn plus 1 and Qn dash 1. Now J would be 1 and K would be 0. Let's find the outcome for first 0 and 1. Qn dash 1, 0 and 1. Here the clock pulse is 1. Clock pulse is 1. J is 1. Here Qn dash is 1. Therefore the 1 would travel through this path and would join here 1 1 and 1, and the NAND gate for 1 1 1 is 0, therefore the outcome would be 0. Now in K it is 0, clock pulse 1, and the Qn is 0, it will travel through this path, so therefore 0 0 1, therefore the outcome would be 1. Now this is a new case and the output would be also new. Let's see what happens. As this outcome is 0, and as I have said that these two gates are in active low condition, therefore the 0 will transform to 1 as it is in the output, that is 1. Qn plus 1 will become 1 as it is. Now what happens is that this one travels through this path. Let me take another colored pen in this path and comes to gate number 4. Now what happens is that the outcome from gate 3 and Qn plus 1 are posing as the elements for NAND gate, that is 1 and 1 are the inputs for gate number 4, therefore the output of Qn plus 1 would be 0. Therefore Qn plus 1 is 1 and Qn plus 1 dash is 0. Let's write it like this: 1 and 0. Similarly, taking Qn is equals to 1 and Qn dash is equals to 0. Repeating the process again: 0, 1, 1, 0, 1, 1. The outcome would be 1, and here is 1 travel through this: 1, 0, 1, 1, 0, 1. The outcome would be 1. This is active low condition, therefore no change, as the output is 1, 1. In active low condition, no change, therefore the output for this remains the same: 1, 0. Now as you can see that Qn plus 1 is 1 for both the conditions. Whether it is 1, 0 or 0, 1, it remains 1, 1 only. Therefore we can say that this state is set condition. Set condition. For the input of 1, 0, 1, two possibilities, we can continue with similar steps as we have done for 0, 0 and 1, 0. The output would be 0, 1 and 0, 1. Qn plus 1 would be 0, 0. If it is both the conditions are 0, 0, then it is called reset condition. Now the last case, 1, 1. Same both possibilities, 0, 0, 1, 0. For this, when you find out the outcomes of Qn plus 1 and Qn dash 1 from this circuit, you will get the outputs as 0, 1 and 1, 0, which is a total reverse of Qn and Qn dash. This state is called toggle condition. Thanks for watching the video.